refers to oxygen. Burns refer to the fact that it is an exothermic reaction. What is a hydrocarbon again? It's a compound that consists only of hydrogens and carbons, like the alkanes and alkenes and alkynes. Okay, so what's the definition of oxidation reaction? It's where you have hydrocarbons that burns, meaning it's exothermic, in air. Okay, what will always be produced? It's carbon dioxide and water, always. So you don't even have to think about it once or twice. It's carbon dioxide and water. So here you already get actually 2 marks in a test or an exam. Okay, now here I say is we have alkanes, alkenes, alkynes, and alcohols. Now I've just put alcohols in there because when you get to university, you're also going to get alcohols that burns in air, or if you go to test papers pre-2014, we will have alcohols that burns in air. You don't need to know it now, but just have it at the back of your head. When you take those things and it burns, meaning exothermic, in the presence of oxygen, it produces carbon dioxide and water. Then also in brackets, not need to know for exam, is when you have limited oxygen, it produces carbon monoxide and water. Okay, now the reason why I put it in there is because when winter is coming up, when you have burning gas or open flames or a fireplace or whatever in your house, please make sure there is a window open somewhere, anywhere that fresh air can come in, because if there is not enough oxygen, your oxygen is being burned up, then it produces carbon monoxide, and carbon monoxide is poisonous. If you inhale it, you fall asleep and then you die. So it's a good way to die, but I'm sure you have your whole life ahead of you. Okay, so that's why in old houses where they still have had old fireplaces and like wood ovens in the kitchen, you'll see those small blocks at the top of the walls with the holes in it, so air can come in and through. Okay, right. So this is exactly what happens when fuel is burned, and by fuel we mean like gas or wood or the gas in your car or whatever. And the reaction is very exothermic. So here I show you a lot of energy is being produced, and I also put in brackets just they use this thing to cut metal because it's so warm. It gives off so much heat that it actually can burn through metal. All right, so now what you need to be able to do is you need to be able in a reaction to complete it and then balance it. Okay, so this is 3 easy marks for you. Now here I tell you how to balance it, okay? But I know you don't like reading, so I'm going to show you. Here you see we have butane. How do I know it's butane? But, for. And how do I know it's part of the alkane homologous series? Because if you look at the general formula for alkanes, how do I know that's the general formula? I studied it. Okay, so C4, 4 times 2 gives you 8 plus 2 is 10. So it's part of the alkanes. Okay, so if you take butane and you add oxygen to it, immediately I can say you get carbon dioxide and water. Always. Now we need to balance it. If you need to balance it, the first thing that you balance is the number of carbons. Okay? 4 carbons, 1 carbon. So you need to put a 4 in front. 4 carbons, 4 carbons. 10 hydrogens, 2 hydrogens. So you need to put a 5 in front of it. Okay, now the rule is, if there's an even number in front of water, then you just balance the oxygens. If there's an uneven number in front of water, then you need to multiply everything by 2. So there's an uneven number in front of water, so we have to multiply straight through by 2. Why? Because at the moment you have 2 oxygens here, and you have 8 plus 5 gives you 13 oxygens. There's no way you can get from 2 to 13 or 13 to 2. That is why you have to multiply straight through by 2. Okay, so we're going to put a 2 there, and an 8 there, and a 10 there. Man, you said straight through by 2. Why are you not multiplying oxygen by 2? Because we're going to balance that at the end. Okay, so now we have 8 carbons, 20 hydrogens, 20 hydrogens. Here I have 2 oxygens, and on this side I have 16 plus 10 gives me 26 oxygens. How do I get from 2 to 26? I multiply by 13. Okay, so that's what you need to be able to do in this or with these reactions. So this is called the oxidation reactions. Okay, let's quickly look here. We have octane burns in excess oxygen. So octane, oct means 8. Okay, and A means alkane, so CnH2n plus 2. Okay, so we have CH, was it 18 plus oxygen gives you. What will it always give you, Seba? No. What will always be produced? And water. Okay, the first thing we balance is the carbons, 8 on the one side, and then I need to put an 8 on the other side. 18 hydrogens, 2 hydrogens, so I put a 9 in front. What is my next step, Ona? Chef, you can read that at the top. Balancing the oxygens. So, that's not the next step. Why are you going to times 2? There's an uneven number in front of water. So I multiply straight through by 2. Let's check. 16. 2 times 18 is 36. 2 times 18 is 36. Here I have 2 oxygens. On this side I have 32 plus 18 gives me 50 oxygens. What do I need to do, Sia? Yes. Okay. Let me first help you. Next one is ethyne. Eth means 2. Ine means it's part of the alkyne homologous series, which is CnH2n minus 2. How do I know that? I studied it. Right. So now that's C2. 2 times 2 gives you 4, minus 2 gives you 2. Burns with excess oxygen. Okay, I'm going to give you 2 minutes to complete this or try this. Nee, ik heb het niet plan. Eerder. Ja. Zo zijn er 3 ingevallen. Ik heb het net afgekomen. sure. Okay, right, so what will form, Courtney?
CO2
And water. Right, how did you balance it, Zara?
I put the 2 in front of the carbon dioxide. And I put a 5 in front of oxygen.
Okay, if you put a 5 there, let's just check. 2, 2. 2, 2. 10. 4 plus 1 gives me 5. How did I know that you are wrong? Because I saw there is a 1 in front of water and 1 is an uneven number. So you have to multiply straight through by 2. Then we have 4, 4, 4, 4. 2 oxygens. 8 plus 2 gives me 10 oxygens, and that is why there is a 5 in front. Okay, now the next one I put there just to show you what will happen. Like I've said, you do not need to know this for a test or an exam this year. But just to show you, you are capable of doing it. It says ethine, sorry, there the E dropped, burns in an oxygen deficiency. So how is that different? Here there's excess oxygen. Here there's an oxygen deficiency, meaning not enough oxygen. So you'll have the same things that react with one another. So again, you'll have oxygen and ethane. But now it will produce carbon monoxide and water. So not carbon dioxide, but carbon monoxide, which is poisonous. Okay, so again, let's say 2, 1, we need to put a 2 in front. 2, 2, now I check, there's an invisible 1 in front, meaning it's uneven, so we have to multiply straight through by 2. Let's check again, 4, 4, 4, 4, 2 oxygens, 4 plus 2 gives me 8 oxygens, so it means there's a 4 in front. Okay, that's the only one that's the exception that you don't need to know. The rest, let's check. Propene, prop means what? Trigloni. And in means it belongs to? Alkenes, do you remember the general formula? CN? Yes. So C3H6 reacts with oxygen, and it will produce carbon dioxide and water. Is ek verkeerd gebalanseer? Wat? Or is it a 3? 2, dis reg. 3. Dankie. Ja. Okay, let's check. 3 carbons, 3 carbons. 6 hydrogens, 2 hydrogens, put a 3 in front. There's an uneven number in front of water, so we need to multiply straight through by 2. Check 6, 6. 12, 12. 2 oxygens, 12 plus 6 gives me 18 oxygens, so it means we need to put a 9 in front. Okay, pent means 5. Ane means alkanes, which is CnH2n plus 2. So that will give you what, Rory? The general formula, the molecular formula for pentane. You can. Mm-hmm. Reaction of oxygen. What will it form, Kutlano? Mm-hmm. Now let's check. 5. 12. 2, so we need to put a 6 in front. Do I need to multiply straight through by 2? No, why not? There's an even number in front of water. Okay, so this, we only need to balance the oxygens. 2, here we have 10 plus 6 gives me 16. So we're going to put an 8 in front. Now, let's say for some reason you missed that part. You multiplied straight through by 2. Then you would have got 2, 16, 10, and 12. What you need to check is this exponents always need to be in their simplest form. Okay, so yes, this is correct because it's the correct ratio, but it's not in the simplest form. Okay, so you need to check for that always. Right, let's see if you can do the last one on your own. Nee, dat is die... This is it. 50. Welkom in die Vrijstad. Was is zo in die Kaap nie? Ja. Carbon dioxide. A 6? That is a 6.
No, instead of a 3 it's a 6 and then you scratch out to come
Huh? Okay, wacht. Could be. Wacht net. What did I do? Ja, nee, is helemaal reg. Six. En nou, je ziet dat ik het net te vinnig gegaan. 12. 10. Nee, beter. Dankie. 24, 34 is 17. Okay, good. Does anyone have a question there? Except for me making mistakes. Alright. Okay, then grade 12. Are we going to go on with the Afrikaans class after school with the addition reactions? Okay, what I want to go to now is your question paper. Ma'am, hand out your question papers back to you. Yes? Wat is fout, Sia? You did not get one.
In my class.
You can sit next to Sebo, who's got it here. Yes? Then ma'am will just give it to you whenever. Okay. And I want to go to question 6. I quickly want to go to question 6. Okay, if you have it on your phone, you can open it on your phone. So this is the March paper 25, question 6. Okay. Okay, so they give you that. Then they say a group of learners are investigating the melting point of A, B, C, and D. D has an unknown melting point X, and then it says all these compounds have a comparable molecular mass. Okay, so you are allowed to compare them with one another, because their molar masses are more or less the same. Okay. Now, the first thing that I want you to do when you get a question like this in a test or in an exam is I want you to write down to which homologous series it belongs to, and thus what type of intermolecular force does it have. Okay? So you see there you have methyl butane, A. So that means it's part of the alkanes, and alkanes have London intermolecular forces. Yes? Rings a bell? Somewhere? Moet ek nog 'n bietjie wag? Okay. Right, next one, butanol, Siba. Which homologous series, what type of intermolecular forces? Butan to ol. And what type of intermolecular force? Say again? No. Hydrogen bonding. And specifically, so this is an alcohol, and it has hydrogen bonding, but specifically one site for hydrogen bonding, because it has one site for hydrogen bonding. The next one, Ona, propanoic acid. And what type of intermolecular force? Yes, it has hydrogen bonding, but specifically two sites, because of the double bond O and then the OH. Okay, and then the last one, Courtney, 2-fluorobutane. 2-fluorobutane. It has, okay, so it belongs to the haloalkanes. And yes, it has dipole intermolecular forces. Ooh. Can you guys read there? Okay, so it has dipole intermolecular forces. Now, what I want you to know and to see and to understand is when we say something has, for instance, butanol has hydrogen bonding, it doesn't mean it only has hydrogen bonding. If you look at butanol, then this whole side has London forces. Because if you look, this is three-dimensional, you look at it from this side, it looks symmetrical. Okay, so it's London forces. It's only this part that has hydrogen bonding. So if you read the memos in the question paper, it will say it, what is the wording there? It says something like it has London forces and hydrogen bonding, but the mark goes for hydrogen bonding. Okay, but if they ask you, let's say they ask you in a multiple choice question, what intermolecular forces do you find here? Then you find their London forces and hydrogen bonding. But which one is the reason why intermolecular forces are the strongest? It's hydrogen bonding that causes it to be the strongest. Okay, so read the question carefully. Okay, right. What did I want to do there? Okay, the next thing we want to look at is what is the obvious difference. Now, the obvious difference is obviously the different types of intermolecular forces. Okay, so what did the learners do? They investigated what will the melting points be. So they chose, I'm going to look at A, B, C, and D. They chose that. And then they looked, okay, what did we get? We got this one's melting point is blah, 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 blah. Okay? So the thing that you change is always the independent variable. And the thing that you measure, that you get, is your dependent variable. Your independent will always go on your x-axis, and your dependent will always go on your y-axis. Okay, I know there's no axis here, I'm just saying if it would have been a graph. Okay, right. Now, before I'm even reading the next question, let me just look at what did they get. They got, this one's melting point is very low. And this one is a bit higher, and this one is the highest. I'm looking at X now. Does it make sense to me? Well, yes. Because London is much weaker than hydrogen bonding. And this one that has two sides for hydrogen bonding will obviously be stronger than that one. Thus, its boiling point is melting point is higher. You see that? Now I'm going to ask myself, where does dipole fit? Is dipole the strongest? No. Is it the weakest? No. It's in between. In between where? It's in between the London forces and one side for hydrogen bonding. So this X must be somewhere between those two. Are you with me? Right, now I'm reading my first question. It says there, define the term melting point. Now, I just want to check, does any one of you have your exam guidelines here in your flip file? Man, just find out. Do you have anything in your flip file? Why not? Remember, when you have to think what is more important, your notes or your exam guidelines. It is your exam guidelines. It's the most important. More than our notes. Okay, but anyway, in there is a definition for melting points in your exam guidelines. Okay, so I have told you this in the past 2 or 3 years, but I'm going to tell you again. When you study, where do you go to practice your definitions? Exam guidelines. You check all the definitions there. Okay? If mine differs from the exam guidelines, you study your exam guidelines definitions. Yes? Yes. You need to go find that exam guidelines. Okay. Right. 6.2 says, give the independent variable for this investigation. So the independent variable is this thing here. So it's the thing that we chose here. Now, what did we choose here? Can we just say the compounds? No, when we chose these things specifically, we compared different things here with one another. So you can either say there it is the type of intermolecular force, You have to write out that whole word. Or you can say the type of homologous series. It's not the length, because they said they have more or less the same molecular mass, so it's also not the mass. So we compared the homologous series or the type of intermolecular forces. Okay. 6.3. What type of alcohol is compound B? Is it primary, secondary, tertiary? Give a reason for your answer. Okay, now I already drew it there on the right hand side. It is what type of alcohol? What did you answer the next question? You did. Zara, what type of alcohol? And why? It is primary. Why?
Because
the hydroxide is always attached to non-carbon. No. Yes? The functional group is connected to a carbon that's connected to this one is connected to how much? 1. This one is connected to 1. This one is connected to 1. If this one, if this one had a carbon here and a carbon there, then it would have been connected to 3 other carbons. Yes.
Problem 2 of item 2.
With that. Geef je helemaal raar. Jo. Is man the only one that's awake? It's butane 2O. So what type of alcohol is this?
secondary.
Why?
Because the carbon that the function is connected to two other carbons.
Yes. The carbon that the functional group, now you can answer this in I think 3 different ways. The carbon attached to the functional group, or the carbon attached to the hydroxyl group, or the carbon attached to the OH group. It's attached to 2 other carbons. You can't say the carbon attached to the O, or the carbon and then not say what is attached to it. Okay? Alright, so it's a secondary alcohol. Why? Because the carbon attached to the OH is attached to 2 other carbons. Alright, 6.4, they ask, is compound C a liquid or a solid at 0 degrees Celsius? Let's check. Compound C at 0 degrees Celsius. That there was its melting point. If something has melted, what does it become, Rory? A liquid. So at 0 degrees Celsius, what will it most probably be? A liquid. Okay. Then 6.5. And 6.5 was a difficult question. It asks there, on this line below, not according to scale, what will be the unknown melting point of X? No, this will be the unknown melting point of X. Okay, so they tell you X is there. Why is it there? And this counts 5 marks. Okay, now the reason why I say this is a difficult question is normally we would have said from A to D the functional group's polarity increases. Thus from A to D the strength of the intermolecular force increases. Thus from A to D blah 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 blah. But here we can't put it in the line. They say X is there. Now compare it with all the others. Okay, now in this line that they gave you, you have negative 159.77, then you have X there, then you have negative 115, and then they have negative 21, and then they have 0. Okay, so they gave you the melting points of all the others. This one here was for A, this one here is for B, this one here is for C, and then this is D. Okay, So D fits in where? D fits in between A and B. Can you see that? So when I'm comparing it with one another, I'm not going to look at C. Okay? Because they already tell you it is between A and B. If they didn't, if they just said, where does it fit in? Then you would have had to compare it with all three of them. Okay? Because then they didn't tell you you can exclude C. But because they said it's between these two, I'm only going to compare D with B and A. Are you with me? Okay. Right. So, I'm going to look at those 4 bullet points. The first thing is the obvious difference that we already wrote down there at the top. So we are going to say A has, what did we say, London intermolecular forces. I'm now abbreviating to save time. B has one site for hydrogen bonding. And D has dipole intermolecular forces. Okay, so already there you have 3 marks for mentioning all 3 because they have different intermolecular forces. If 2 of them had the same intermolecular force, then you would have gotten 1 mark for saying they have the same one. But since they're all 3 different, you can have 3 out of your 5 marks already. Okay, the next thing that I'm going to mention is which one is stronger. Okay, now what am I comparing? I want to compare D with B and D with A. I want to say why D is in the middle of those 2. So I can't just say this one is the weakest, this one is the strongest. I have to compare D with this one and D with that one. Okay, so I'm going to say D has stronger intermolecular forces than A, right? Because dipole is stronger than London forces. And I'm going to finish the story between A and D. So D has stronger intermolecular forces than A, thus more energy required to overcome intermolecular forces between molecules of D than A, thus higher melting point. I'm abbreviating lots now. Please do not abbreviate like that in a test or an exam. Okay, and that they counted 1 mark. Okay, because it was one idea. Okay, so let's just go over this again. What did I do? I want to explain why D is in the middle. So I'm first comparing these 2 with each other. Okay, so I stated all of the intermolecular forces. Then I said D, since it has dipole forces, is stronger than A. So it will require more energy to overcome intermolecular forces. Thus, it will have a higher melting point. Okay, so I compared those 2. Now I want to compare these 2 with one another. Okay, now I do not have space. So underneath you're going to say, right, do you want to mention D or do you want to mention B? B. Okay, let's go D. D has weaker intermolecular forces than B. Okay, so you can't just say D has weaker than B. So you have to compare the 2. Thus, less energy needed to overcome intermolecular forces between molecules of D. I'm zooming in. Thus, D has a lower melting point. That's a D. Okay, any question there? Ma'am, can you explain this again? What's happening? Are you fine? Okay, so grade 12. I have some bad news for you. Since you got this question now, and since they figured that the teachers went through the questions thoroughly, that we just did, alright, they now consider this question not difficult anymore. Now this question is considered medium, easy, because you've seen it before. Okay, so when you practice for June exam, go through this question again. Make sure you understand. If you don't understand, come ask. Now, can you just please explain again? My head is not coping, whatever. Are you with me? Okay. All right.